Hi everyone, and welcome to another NetBeez webinar. Today's webinar is on how to do packet sniffing on Linux, and more specifically with tcpdump. My name is Panos Bouzis. I'm your host for today's webinar, and I'm a co-founder and CEO of NetBeez. A few words about today's agenda. We'll start, of course, by saying a few words about tcpdump. What is it and what it can do for you? We'll show you what the lab setup looks like that you can use to either practice on tcpdump or use it on a real-world environment. And of course, we're going to dive into a live demonstration of tcpdump, right? This is a live demo webinar, I would say. So if you have a Linux prompt in front of you, then I invite you to follow along. I'll try to keep a reasonable pace so that you can follow along with what I'm going to be doing. But even if that's not the case, you'll get a recording of the webinar. You will be able to follow the webinar at your own pace. Talk about and one of the most important, I think, webinar is use filters, because when you're doing some packet capturing, usually the amount of traffic is not readable or traceable by a human being. You have to make sure to be able to isolate what exactly and then sort the traffic that you have coming through your interfaces. So tcpdump is actually more than 30 years old, okay? So it was first released in 1988. The fact that it's been around and it's being updated and maintained for 30 years now, it means that many people find a good use of it, right? And what it pretty much does, as the name implies, is dumps traffic, not only TCP traffic, but other types of traffic as well on your command line interface in Linux host. A close cousin of tcpdump is Wireshark. Some of you might have heard of it. It's a little bit of a newer tool, very similar functionality. I think Wireshark used to be free and maintained by an open community, but now I think it has been purchased by a private company, but I think it's still free and open. And yeah, if you want to install a tcpdump, at least on Linux host, you can just type the command sudo apt get install tcpdump. It's in all repositories, so you'll be able to. And actually, you might even find it pre-installed on main Linux distributions, right? It's so popular and useful that many Linux distributions include it by default. And of course, you can find instruction how to install it on other operating systems online. The point of the webinar is to demonstrate and educate you a little bit, and educate you on how to do packet sniffing with tcpdump, right? I'm not aspiring to make you experts in tcpdump. Actually, it takes a while to become an expert because of the complexity of packet capturing, but also because of all the possibilities and options that the tool gives you. However, I want to give you, I would say, a pointer. So after this webinar, you'll know what tcpdump can do for you. And when you get into a situation where you need to do some packet capturing, to do some troubleshooting, then you know where to refer to, right? And be able to do some at least quick packet capturing that may help you to save the day. So it's a free and open source command line tool. So it doesn't support only on Linux. You can find for Windows and Mac operating systems, and works equally well on all of them. In this case, we're talking mostly about Linux because that's, I would say, where most people use it, and that's where I learned how to use it. So. But whatever I'm going to show you today, you can extend it to, of course, other operating systems, although other environments might have better and more, I would say, graphical user interface environments rather than the command line interface that Linux has. And what you can do, right? So tcpdump, of course, is its first purpose to analyze network problems. You can go down to the packet, down to the byte, or even bit of its packet and see what exactly is going on. So if you're trying to troubleshoot any network connectivity problems, any timing issues, tcpdump is a tool that can help you with that. And of course, you can go higher to the application level because you can, of course, debug higher level things by looking at the payload of packets. And again, if you need to go down to the byte or bit level of a packet, you can do it with tcpdump. So that's for troubleshooting purpose, I would say, on an ad hoc basis. Then if you use tcpdump on a more continuous way, like maybe run for a period of time or continuously on a system, you can use it for monitoring and gather statistics around network activity. That goes a little bit closer to, I would say, packet inspection, which is a whole different set of tools, because there are tools that can do this very efficiently and actually extract the information that you need in a very nice way. tcpdump, I would say it's not ideal for that, but if you want to hack together a solution that can help you to get some numbers quickly together on a specific network, then it's a tool you can use very quickly and very easily. So the lab setup here, so there are two main ways you can use tcpdump. One is on promiscuous mode on a switch. So you have a switch, you plug in your machine, and then you gather all the traffic from all the interfaces, right? Of course, as you can imagine, here, the very important thing is to be able to isolate the traffic you are looking to isolate. You cannot really sort the traffic manually, right? Or even on an offline, even if you save all the packets and try to process them one by one at a later stage at your own pace, tcpdump can capture so much information that might be intractable to do it manually or impractical. So we'll talk about those filters later on. And the other way, of course, to do it on a specific host when you have a point-to-point connection and you're trying to look at what's going on between two different on a specific connection from your host to another host, right, at the network application layer. And that's all with the PowerPoint. I didn't want to spend too much time on this, of course. I want to dive into the actual live demo, and let's look at this, right? So let me clear my screen here. I believe you can see it. So now, I have here my Linux box, and of course, I'm going to start by typing the command tcpdump. One of the most basic options you have to give tcpdump is the interface you want to use for capturing. So I'm going to say -I stands for interface, eth0. So of course, you have to know the interface, the interface names of your machine. But you can also use the keyword any, which of course tells tcpdump to capture traffic from all interfaces. And the other thing you have to keep in mind here is tcpdump needs elevated privileges, because you need to capture traffic from from sockets at the lowest level. You need to be able to run this either as root or use the sudo keyword to allow tcpdump to run. I'm going to hit enter, and I'm going to see here a deluge of packets here coming through my machine. They won't stop unless I interrupt this by hitting Control-C. And if I do that, I see here that in 10 seconds maybe, I got 2,600 packets that were captured here. And tcpdump will keep going, right? So there's, of course, an easy way to restrict the number of packets that you capture. So I can say, if I use the -C option, stands for count, and type the number of packets, let's say 20, it's going to stop after 20 packets. Let's take a quick look here and see what really high level what's going on. So I see here, of course, each line represents a packet here. And in some cases, you see here that I see the actual FQDNs of the host a packet is going or coming from. In this case is, of course, a Google DNS server that I'm hitting there. And so keep in mind that what that means is that tcpdump does itself a reverse lookup of IPs. So it creates itself network traffic, right? Because it does these DNS queries when it tries to do a reverse lookup. And it also, as you can see here, It also does sometimes from some very well-known services like SSH, SMTP, Telnet, right? It tells you what type of service actually, is sending this packet. Often, actually, you don't want to have this reverse lookup with tcpdump, and to do that, you can use the option -n. So if I use the -n option, I'm telling tcpdump, hey, don't do this reverse lookup. I don't want to. And actually, that's how we use tcpdump in most cases, because it's easier to filter by the actual IP and port numbers than strings of data, right? Of services. So now let's look at the output of tcpdump and see what information it gives us, right? So on the second line here, I'm gonna here, right? I see the capture size. So it's here is to any6 to 200,062,144 bytes. That's actually 2 to the 18th, which is 256 kilobytes of data. So this tells us that for each packet that comes in, tcpdump captures that many bytes. And of course, that's a big number of bytes. And what this tells pretty much that for every packet, tcpdump calls and saves the whole packet, right? So if you're gonna do just, let's say, if you're trying to troubleshoot an issue or looking for some evidence of lost or out of order packets, you just need 6496 bytes. You just need the headers. But if you're trying to troubleshoot like application layer issues that need the actual payload of a packet, then you have to go to higher values, right? And actually, there is a way to restrict that number. So if I use the option -s, let's say 96, I'm gonna see now that the capture size was much smaller. Okay, so you have the option to change everything. Now let's look again at the output of that that command and see what information tcpdump gives us for its packet. So there are many fields for its line, for its packet. So the first one, of course, the timestamp of the packet when it was captured. Okay. So in this case, it gives us also milliseconds and also microseconds resolution, and that's important because when you're troubleshooting timing issues of packets, then you need to go really to that fine timing resolution, right? So tcpdump gives you that information. Then it's the protocol, and then it's the IP dot and the port of the source of the packet. Of course, this is a SSH session packet on port 22, and that's the destination IP and the port of the receiving end of the packet. Then flags, different flags, TCP flags. So TCP gives you, for each flag, it represents its flag with the first letter of its name, sync, ping, push, etc. And the only exception is the acknowledge, which is represented by a dot, like you see here. Okay. Then are the sequence numbers. These sequence numbers, of course, are the TCP sequence numbers, and tcpdump on the first packet captures, it gives you the absolute TCP numbers. Okay. I'm sorry, sequence numbers. And then it switches to relative sequence numbers because they are easier to read, obviously for us, right? For reading purposes and troubleshooting purposes. So let me show you. Actually, let me do a different capture here and show you something else. So don't worry about what I'm using right now. We're going to explain this syntax later on, but okay. So let's look at this again, right? So the first is the absolute sequence numbers. Then we're switching to relative sequence numbers, 48 to 96, and so on and so forth. And then it's the acknowledgement, right? For example, you see here in this case, you have packets 1 to 49, and then the acknowledge for the 49 packet size. Then is the window size, the receiving window size, 443 in this case, and then you have the length of the packet. So for example, if I go here, I see is 40 sequence 49 to 161, and if you do the math here, you will see that the length of the packet is 112 bytes. Okay. So actually, you have the option if you want to disable the relative sequence numbers by using the -s option here. So I'm going to do this. I'm sorry, capital, yeah. Okay, here it is. All right. So if I again trigger some traffic here, now each line gives the absolute sequence numbers, not the relative ones. You see how much more difficult it is to read than the relative sequence numbers. So the default option is the relative sequence numbers in this case. Okay, so we captured the output, and now let's talk about how to save the output in a file. So it's very simple. I'm gonna just type the simple tcpdump. I'm going to use here the finite number of packets. I'm going to let tcpdump run for a while, and of course I use the -w stands for write. I'm going to type the name of the file, pick up, and hit enter. And of course now tcpdump is working, capturing some traffic. The bad thing here is that you don't see any output of how many packets are being captured, what is the progress. To get better visibility to that, you can use the -v option, where now I'm gonna see, hey, tcpdump tells me, okay, I got 40 packets, 70 packets, so on and so forth. So I have some kind of visibility of how many packets are being captured. Live update. So the output file here that's going to be produced, I can see it here. So in 10 seconds, produce 25 kilobytes of data. You know very well that this file size can become very big if you let it run for a long time and you have some serious traffic on a specific interface. Things actually are pretty quiet on this machine here. I'm demonstrating tcpdump. And that thing to remember is that these files created are not human readable. So you need to use tcpdump again to read them. So how do I do that? I use the -r option. I can say -r output, and I'm going to see actually as if I was running tcpdump on my command line on live, right? Just dumps here the contents of the file, but since the file now, I can browse it by using like pipe less. I can go page by page. I can search and stuff like that, right? So I can, of course, post-process it offline at my own pace, so I can send it to somebody else. If I'm troubleshooting something, I can send it to somebody else to get some advice or some feedback, right? If you're collaborating with somebody. So very useful thing too. All right, so let's talk about filters, which is a very important topic. And again, you have to be able to use filters well in order to sort only the traffic that you really need to see. So let's start with a very basic filter. I'm going to say use the keyword host and then type the host that I want to, that is involved in packets, right? And I want to capture. So now any packets that come or go to that host are going to be captured here. As you can see here, I open a second window to trigger some traffic. And because I want to see if that's correct, right? So as you can see here, I'm pinging this host and I'm capturing this ICMP echo reply and requests packets, right? So from my machine here, I see the echo request leaving, and coming back, I see the echo replies. Now, to be more fine-grained here, you can specify if you want to capture packets where that host is the source of the traffic. Okay, so now it's going to be only packets where this is the source. So you see here, I see only the echo replies coming back from that host. Or if that host, I want it to be the destination. So I hit that, and then I'm gonna do again a ping. I'm gonna see now only the packets going towards that host. So pretty straightforward, and a very basic filter that you should always use when you are sorting through packets, right? Now, the other thing you can do is that you can, of course, combine different kinds of filters by using logical operators. So let's say I want to capture traffic that goes only between these two hosts. And I can use the AND operator. I can say 172.30.10.14. So 30.10.14 is the IP of the machine I'm showing you here right now. I hit enter, and now I can, let's trigger some traffic again. I'm going to that host, 30.07, okay. So you see that. But if I try to ping, for example, 8888, I won't see anything there because it's not traffic I'm going between 31.0.14 and 30.07, okay. Great, so let's clear that. So we show you how to use logical operators. And now let's talk about ports. Again, very basic, very important thing to do is to be able to filter traffic by port. Let's talk about port 53, so which is the DNS, of course, port. So now I'm going to see only ports coming from that specific, only traffic related to that specific port. I'm going to do a wget here on youtube.com. And here it is, right? So I see here that I got this request going to this Google DNS server, okay, for an A record on youtube.com, and also a quad A record. So the A record is for IPv4 and quad A record is for IPv6. And as you can see here, this host replied back to my machine here with the IPv4 A record and the IPv6 quad A record. And actually, as you can see here, there is another request that was triggered. That's probably a redirection where YouTube redirected me to www.youtube.com. So I have now, actually, as you can see here, the A record has 6 different IPs that I got back. While actually I killed it afterwards, so we don't see here the quad A record, but it should be only, actually no, this I think that, yeah, this is the quad A record, which is only one of them, right? Okay, so this is how to filter by port. And to make it a little bit more interesting, let's talk about compound expressions. So this one you combine, again, a little bit more complicated logical operators. Now, I'm gonna, the traffic, okay, that is related, I'm gonna use the -n so it doesn't resolve any, doesn't do any reverse lookup to my host here, but it involves port 80 or port 443, okay? So pay attention here to the double quotes I used. These are necessary to get the correct results. Otherwise, we're going to have a syntax error. And now let's do this. Let's run a ping test to google.com. And you won't see anything on the other window because ping, of course, doesn't do anything with ports at all, right? But let's try also a curl to google.com. And to make it more specific, let's say HTTP, so it's port 80. I'm going to see the output there. And if I say also HTTPS, I'm also going to see the output because it's port 443, right? So you can combine logical operators to create a more complex expression to have more fine control over your over the packets you capture. We have this as well. And the next thing is how to actually filter by actual networks. Okay, so Now, in this scenario, I wanna capture traffic, display only traffic that leaves my network here, the subnet that this host belongs to, and goes outside that subnet, goes to the internet anywhere else, but I don't want any traffic that comes or goes between any host in this subnet, right? So I'm gonna use now, so I want traffic, right, that has as source network. You have to use the net keyword, 172.31.0.0.16, okay? And the destination, okay, shouldn't be networks, my own network, okay, and not this other subnet which I'm part of, okay? This network is correct. Okay, so I have here some ARP requests, but I'm gonna show you here, I'm gonna ping this host here that belongs to the same network like as mine, right? So I don't see here actually any of the ICMP packets coming here. So don't get distracted by the ARP request here, but you notice I don't see the any ICMP packets captured. Now let's try to ping google.com, which is outside my networks here, the networks I defined up there. I see here the ICMP request coming back and forth, right? Or let's do a curl request to google.com. As you can see, I get the packets captured over there, right? So you can specify specific network subnets from and to, and again, this is useful again when you're troubleshooting for specific traffic between different networks or subnets. Now, types of traffic, of course, you can specify what type of traffic you want to capture. You can use, of course, all different filters. ICMP is going to capture only ICMP traffic, ping requests, TCP, etc. Right? So if I say here ICMP, you don't see anything going on here. If I try to, let's say, do a curl request, which is not an ICMP request to google.com, you won't see any output. But if I try to ping google.com, you will see that ICMP traffic being captured. And flags. So again, for TCP traffic and TCP packets, I can filter by specific flags and the status. So here's the syntax how this looks like. TCP, I open bracket and I say TCP flag, and I say TCP syn. Okay, so I want to see packets that have this flag non-zero, right? So it has an option. So to trigger that, I'm gonna do a request to this. I didn't hit enter here, so I'm gonna hit enter. I'm gonna do a request here to this host on this port. I can see here the sync flag, right? I can use, if I want, the reset flag. Okay, RST. And let's try port. Okay, so you see here that it's set acknowledge flag, right? So you can sort by any kind of flag that is out there. And that concludes the section that I'm talking about, the different filters. To summarize, you can filter by different things: host, port, source, host, source, port, subnets, flags, and so on and so forth. And there are many other filters that are out there that tcpdump provides. Of course, in 15 or 20 minutes, I wasn't planning to be exhaustive, but give you an idea of what you can do, right? And now it's up to you when you really get comfortable with tcpdump to sort through all these different options you have that the tool gives you. And I'm going to close with a couple of options that tcpdump provides to control the level of output you get when you run the request. So the first option is, let's say, port 80, the minus XX option. So when you use that, you're gonna get bit by bit, byte by byte information of all the packets coming through, right? As you can see here, it gave me for each packet, apart from all the, like information that already gives me, it gave me the byte by byte information. Actually, on the right-hand side here, you see the actual text or the payload of the packet, right? So if you want to go into more detail, you can do it with tcpdump. I would say if you ask, it's going to be there. The -A option is going to give me, it stands for asking, it's going to give me, when possible, the ASCII output of a request. So I did here a curl request to google.com, and I got here, as you can see, the HTML actual payload, the actual text of the HTML page of google.com as part of the output. And another option that gives you more verbosity, you use the -V. If you use 1V, you get some additional information, 2Vs more, 3Vs even more, right? So again, I can do this and I can do this request and see that it gives me again a different set of information. So you have to tailor in each case what really you need. If you need the byte by byte information, you can go with the -XX option. If you just need the text, the -A option, and verbosity gives you a different level of in between, I would say, information about its packet. And the last thing is about timing, which I think is also very important when you're troubleshooting timing issues for packets. And at this point, I would like to tell you that we're close to the end of the webinar. So if you have any questions, please send them over either by chat or on the Q&A session. I will cover them after I'm done. So timing. Now, here it is. Let's use the -T option, of course. And if you use the -T, actually it does the opposite, gives you less information about timing, because it's going to strip the first field of the output. So you don't have the timing information here. So if it's not important for you, if it just, occupies space, then you can get rid of it with the -T option. If you use 3 T's, it's going to give you now, for each packet, for the first packet, it's going to start with 0. And each new packet is going to have an incremental time, which is its relative time compared to the previous packet. So again, this is very useful when you're trying to do timing troubleshooting of packets. You want to see what time they're coming in, how long it takes, and relative to the previous packet, right? And if you use the 5 T's, I promise that's the maximum number of T's you can use, then tcpdump gives you, okay, hit enter here, tcpdump gives you, the first packet is 0 again, and then each additional packet is the time compared to the first packet. So you see here the second packet arrived 13 milliseconds after the first one, and the last packet here of this capture was 64 milliseconds after the first packet. And with that, I'm done with the live demonstration. I hope that some of you followed through and followed along, and you got your hands dirty with tcpdump a little bit. Now, a few words about NetBeez. So NetBeez is a network monitoring tool. I'm going to show you how this ties with tcpdump. It's a network monitoring tool that allows you to capture user experience from remote sites by using agents. I'm showing you here a demo installation we have about NetBeez on NetBeez, and each one of these thumbnails now is an agent. It's a hardware box. It runs Linux, and for its monitoring purposes, it captures and tries to get end-to-end information about user experience, right? So you see here, I'm having this agent in our office in Pittsburgh. It's a hardware box there, and from that agent now, I'm running a series of tests towards some applications, websites, hosts that are important, and I want to measure performance and availability from the Pittsburgh office. So, for example, I'm monitoring YouTube, I'm monitoring Reddit, and CNN, and so on and so forth, right? Now, where this ties with tcpdump is that its box, it's one of these agents, a Linux box, and we provide here on the console a command line interface for the box, right? Let me see here, let me become root. So this is similar to an SSH session, but the convenience is that instead of having to SSH to that remote box and access it, which might be even difficult or sometimes impossible if it's behind firewalls, if it's a NAT network, you have this console here at your fingertips on the dashboard. And apart from all the monitoring you can do, you can use this console for troubleshooting purposes, for get visibility into the specific network that the box is in, right? So, and of course, part of what you can do here is you can run a TCP dump command if you want to capture any traffic on that specific box and do your troubleshooting, so remote troubleshooting on that specific network. Okay, so now, and I'm gonna close with answering a couple of questions about NetBeez. Let me switch to the Q&A. So I see one question about what's the difference of TCP dump and packet capturing, other packet capturing tools. Of course, the packet capturing business is a big business. There are many vendors out there that do just packet capturing. There's specialized hardware that is being sold. It's not cheap, right? You can do deep packet inspection and get statistics and do monitoring with packet capturing. I would say these are more advanced tools that you can use at your network specific points to do this deep packet inspection. TCP dump, I would say, is a more lightweight, free open source utility you can use to do some ad hoc troubleshooting when needed. Another question is about how much CPU TCP dump, let's say, uses when it captures traffic, right? So it can be taxing on your CPU, depending on your platform, of course, especially if you're trying to capture, lots of traffic on a very busy switch. Let's say you're on a promiscuous mode, you're capturing traffic from all interfaces, right? So now there are a few things happening there. First of all, you need the CPU power to capture the traffic, and then you also need the disk I/O to save that traffic on the file, because I cannot imagine you will be able to look at this traffic in real time in your console. You need to save that file on your disk. So you need to have good disk I/O first to write it there, and have enough disk space to write the file if it's a big file, right? So yes, it can tax your system, but keep that in mind, right? When you do it, sometimes you might run your system out of resources. You might run out of disk space. Let's say I had many cases where I left TCP dump running for a while, and it completely consumed my disk space, and that's the only way it stopped running. So don't do that. Now, another question here is what kind of tools can I use to analyze the TCP dump output? So the output is in this pickup format that I kind of implied when I show you how to write in the file by using the pickup extension. So you can read of course the pickup format with TCP dump itself, but because it's a universal format that can be used by other tools, if you capture a file, and even if you're a colleague or somebody you're getting help from, send the file to, and they don't have TCP dump, they can open it with Wireshark, with other tools that actually do packet capturing. And one last question: what does promiscuous mode mean? So promiscuous mode, okay, that's yeah, I didn't cover that. I'm gonna say really quickly. So promiscuous mode is when you have a switch like this, and you can configure the switch to mirror all traffic from all interfaces on a specific interface. So here, for example, if I plug my laptop on this one interface, and I put the switch on promiscuous mode to mirror all traffic on this interface, I can capture all traffic of all interface on this specific interface. I can capture all the switch traffic on my laptop with TCP dump pretty much. I have a few more questions here. I'm going to follow up with individual questions later offline because we're running out of time. Thank you all for participating in this webinar. Thanks for your interest in tcpdump. If you have any questions, follow up with me offline. I'll be happy to help or answer any questions that may come up when you're doing some troubleshooting or packet capturing. That's all for today, and see you at the next NetBeez webinar. Bye, everybody.